Hello, my name is Bryn Thomas and I'm a partner in the Agricultural and Estates team at Harrison Clark Rickabees based in the Cardiff office. I'm also a farmer and together with my family, we farm a pedigree suckler herd in the Brecon Beacons in Wales. We have here with us today Florian Richter, who is a co-founder and CEO of Muddy Machines. I will, of course, let Florian explain more, but for those listening, Muddy Machines is an AgriTech and robotics company that helps automate crop harvesting. Florian, thank you very much for being with us here today.
Yeah, thanks for having me, Bryn.
So why talk about AgriTech? Well, it's all about being a part of the solution and not the problem. The world population has grown at an alarming rate. In 1900, there were fewer than 2 billion people on the planet. It's now around 8 billion. AgriTech innovations and automation will bring about efficiencies, enabling us to feed the world population whilst at the same time mitigating environmental impact. There are many issues being faced by the farming industry at the moment, such as lack of labour, drudgery and environmental concerns. And these concerns have become clearer recently with the shortages of fruits and vegetables that many of us have recently experienced across the UK due to the weather conditions across Europe. HCR have previously partnered with Muddy Machines when Muddy Machines exhibited at our AgriTech zone at the Royal Three Counties Show in 2022. The dedicated zone connected farmers and agricultural businesses with the organisations, bodies and academics who provide research, funding and development for cutting-edge machinery, technology and equipment for the farming industry. So Florian, how did it all start for you in terms of what was your reason for being and your vision or mission that you wanted to set out on?
Yeah, that takes us back about 3 years. We started in 2020. My co-founder Chris and I, we met at a startup incubator called Entrepreneurs First. But we both went in there with a strong intent to do something in agriculture. We felt that there was a lot of technology that could still benefit agriculture to really forge a path to benefit people and planet. So that's actually the mission statement of Muddy Machines now. And when delving into the sector a bit more and really speaking to farmers, we understood that one of the key issues for those in horticulture and selectively harvested field vegetables, so the kind of fruit and vegetable sector, was the labor shortages. So our vision is now to sustainably solve agriculture's labor challenges with robots, because that's what Chris has as a background. He's a robotics engineer with work he's done for Dyson and Deliveroo. And so, yeah, with that skill set, we felt that we should have a crack at solving this.
Okay. And in terms of the specific, when you were starting up, in terms of the sort of launching that vision and initiative, what specific challenges did you face?
Well, startups that are doing anything to do with hardware are always regarded as nice but won't scale or are very capital intensive. So you get some resistance from investors or also incubator programs very early on. It's like, oh, well, is this really something that you want to do as a venture style business? In addition to that, in 2020, farming was still very much regarded as a industry that is hard to innovate in, that is something that hasn't seen a lot of venture investment. And so we're kind of fighting on two fronts here with our solution. I mean, this is a problem that you cannot solve with a smart app or optimizing the way farmers work. This is you have to get dirty, you have to get muddy, and if you want to get crop out of the field, right? I mean, this is probably something that I should have mentioned. Labor shortages means that farmers have no people to get the crop out of the ground. And if you're talking about crops where you can't just deploy a combine harvester and just cut everything off in one go within a day or so when you're going into a field, you're relying on people. And so some farmers need thousands of people on a ongoing basis during the harvest season to go through their crop on a day-to-day basis and pick that broccoli, pick that asparagus, pick that apple at the moment that it is ripe. And I mean, this is probably some kind of context that people need to have heard.
So it's precision farming, isn't it, that you're helping essentially?
Yes, exactly. That's the labor-intensive element of farming today, is this kind of precision that only people can do with the eyesight they have, with the understanding of what they're looking at, the comprehension, the perception, the visual analysis, and then also the haptic element of the hand that is able to pick or to weed or to prune specifically in that spot, and understand how it needs to be done differently from the environmental circumstance, right? If I want to cut off something, I can't always cut off from this angle because there might be something else in the way, right? So I need to do it from a different angle, and that is something that's very difficult for a purely mechanized solution to do, and that's where the whole machine learning, robotics, and AI comes into play. Okay.
And for the farmer, of course, you've got that limited window to sort of harvest the crop with asparagus, and it's the alternative, if you don't get that out of the ground, is massive financial loss.
Yeah, the clock's ticking, right? I mean, in a crop like asparagus, you have to harvest on a daily, almost twice daily basis, because they shoot up to 16 centimeters within a 24-hour window.
Wow.
And you cannot afford to have a shortage of field hands there. I mean, a grower told us that if you're only one person short in a season, you're losing about 25,000 pounds that season.
Staggering, isn't it? Yeah. So can you tell us a little bit more, or provide some more specifics about the actual machines that you designed and created?
Yeah. Our approach from the get-go was that we needed to build a platform. Platform is a word that is often used in tech, but so what do we mean by that? The issue you have with crops is that they are all kind of insular little markets that by themselves are relatively small, and if you build a technology just for one crop, you're really limiting yourself in the kind of applicability and the impact you can have. So we said we can't just build we started with asparagus, but we said the technology we're building for asparagus harvesting needs to be applicable to other crops as well. So that means you need to build first of all, a drivetrain tool carrier platform that can carry all sorts of different tools and drive through a set of field environments, so that you can say we start harvesting an early crop early in the season. So asparagus harvest is between March and June, roughly. And then for the rest of the year, what does that machine do, right? And so our approach is very well, we'll take this tool carrier back into our workshop. We put a different tool in and then send it out again to a crop that is harvested later in the calendar year, such as broccoli or courgettes. You can look at certain ornamental flowers that are harvested even earlier than asparagus. So you get really a use case out of this, quite expensive hardware. If you're putting advanced computers and batteries, etc., in there, then you want to use that as much as possible throughout the year. And that's also an element of sustainability, right? We could probably make the commercial model work that you only use it for a couple of weeks and then put it in the shed. But we really want this, our platform, to be in the field, doing work, saving labor, optimizing yields as many months of the year as possible. Okay. So I can maybe show you a couple of pictures of how we iterated on that platform throughout the last 3 years. So
Please do, that'd be really interesting, yeah.
Yeah, so in the first year, I'm just scrolling through some videos here to find so this is Sprout Mark 1.
Right.
So you can see this is something that we built, basically Chris and me and 1 or 2 engineers, very crudely put together. This is the owner of Corbury Farms, and this is the test field that we have.
Okay.
But there you can see, we prove the concept on a very slow, rudimentary basis. Can you grip an asparagus? Can you put it into a tray? And then the year after, we built this, a much more advanced and more autonomous version of Sprout. This is Sprout Mark II.
Okay.
That already then had autonomous driving features, a much more advanced tray system to drop off the crop, was able to harvest quite a lot faster, had major upgrades in terms of its in-field drivability.
So more commercially able machine.
Yeah, not yet commercially able, and this is still a prototype.
Right.
But it had some concepts in there that will make it commercially viable.
Okay.
Right? And here you can quite easily see the gantry, or the tool that the robot takes on board, and that can be removed. So everything that you see that is white and red, that is the actual robot, and the metal bits. So those are the ones that are we can swap out.
Okay. And battery operated.
Battery operated.
Yeah.
Yes. This is Sprout Mark III. This is what we're currently testing in the field with this year. Okay. So this is now fully waterproof, a lot more robust. But you can push this further and further and further every year. But yeah, that's where we are. This is the battery power, so electrically powered, self-driving, lightweight field robot.
Wow, brilliant. Perhaps with the ambition of moving on to a herd of them, if you can have a herd of machines.
Yes, exactly. I mean, once you have it working, you need to scale it up, right? Yeah. And our insight is that especially in horticulture, soil compaction is a really big issue. So if I pass through a field daily, I really don't want to do that with something that is as heavy as a tractor or even as heavy as a combine harvester, right? Our Sprout robot is just under half a ton, which distributed over 4 wheels it has a compaction impact similar to what you have with your foot. And so on that basis, you're right, we need to put a herd of robots into the field instead of making Sprout bigger and bigger and bigger to have a higher throughput.
Okay.
Yeah. Opens up some very interesting opportunities in terms of how do you share the workload of the rows in between the robots. You know, some rows might be faster to harvest than others, and then these robots can coordinate and say, okay, robot A is done with row 1, can it go to row 3 now, while robot B is still on row 2, finishing that up, and then it will skip over to a couple of other rows. And yeah, this is similar how it's done with people, right? People walk through the field, and some are quicker than others.
Yeah, and there's a huge emphasis, obviously, at the moment, isn't there, environmentally, on minimal soil disruption, no till. You know, in terms of better carbon capture from that.
No compaction, no till, right? Our vision is to be compatible with these practices and not build technology that then says, well, okay, we solved the labor problem, but we're actually causing problems on the other side of things. Yeah,
that's fascinating, brilliant. Do you see that farming and food production then can go hand in hand with the environment?
Oh, absolutely. I mean, it must do, right? I mean, a healthy environment means healthy yields. And if you're looking after your soil, you will have a profitable business in the long run. And I think farmers really do understand that, right? I think there's a problem right now with chasing short-term profitabilities, trying to make to reach quotas or to hit certain wholesaler price targets. But you don't farm a field and then do something else next year, right? This stays within your system, and if you treat it badly, in a few years' time, you will have very, very, very high input costs or just terrible yields. And breaking that cycle is an incredible opportunity for agriculture, right? I mean, a world where we have profitable farming without high input costs.
It's a hugely important resource, isn't it, soil? And it's I think, as someone said to me the other day, you know, look after it because they're not making any more of it.
Yeah, but by land they don't make it anymore. Is the other saying. Yeah, and I think there is a real opportunity for first world countries to look after their soils, to regenerate their soils, and to keep farming and keep the production of as much produce as possible local.
Yeah.
Right? Because that's the other angle. It's not only the financial gain of farmers that we are aiming for, right? It is also to contribute to a resilient and healthy food system. And if you are putting more and more land out of production because you can't get the labor to farm it, etc., people still need to eat, right? So you're going to get this produce from abroad, ideally from close by, but still there are problems with countries like Spain or Morocco that have drought issues in their production, or you have to get it in from overseas, which then causes quite significant food miles. The produce also doesn't get a lot fresher by being shipped, even if they preserve it very well with cold store and other techniques.
Yeah.
And there is a reason, right, why Great British asparagus is so highly priced when it's in season, because it's really, really good. And this is, I mean, you can say the same for any crop that is produced locally.
And how do you see the future of AgriTech moving forward?
Well, there's so many aspects to AgriTech, right? We have this whole indoor controlled environment farming. I think this definitely has its place for certain crops and for certain countries. We have a massive opportunity with the near orbit satellites and how this brings more internet into rural areas and enables additional farming and precision farming technologies in the field. I'm very excited about precision farming and the opportunities that brings. And we are starting now with harvesting, and we are expanding from one crop to another. But we're in the long run, I think we can do so much more than just harvesting, right? We can do either our own technology or third-party technologies and put precision sprayers or mechanical weeding solutions onto the platform and deploy that either while we're harvesting or on days where no harvest is necessary, and really take the pain out of this labor-intensive farming, and I think attract more people, more skilled people on a full year basis into areas where farming is done, and not have this big fluctuation of seasonal labor, which is separate housing. It's almost like a separate community that pops up during the harvest season, and then for the rest of the year, it's the face of these communities changes. So I think robot operators or precision farming operators that are attracted to the industry, to these regions on a more long-term basis, I think could have a massive benefit also for the communities.
Yeah. And in terms of what next for Muddy Machines?
We are very much in the middle of the season right now, sending our robots out on a daily basis, optimizing, making improvements. And we want to now get to a place where we know how many people is one robot capable of replacing, to have a reference point. This is what it can do. And build on that and come back next year and do a couple of fields with our robots and scale the business on that, right? Like finishing touches to the technology, then scale in asparagus and bring on additional crops. Later this year, we're going to do some trials in courgettes, which I'm very excited about, a very different crop. And that should be really good.
Good. Well, Florian, some really interesting comments from you there, both in terms of what you've achieved at Muddy Machines and in respect also the wider issues that we're facing within AgriTech and innovation. Thank you very much for your time.
My pleasure. Thank you.